related to kinematics. We are going to talk about important terminology related to kinematics. Okay, so what is that? One is distance, the other one is displacement, next speed, after that uniform speed, next non-uniform speed, after that average speed, velocity, average velocity, acceleration, uniform acceleration, non-uniform acceleration, non-uniform acceleration. These are the important terminology which we have in this chapter, right? Let's talk about distance. Okay, first we shall have a discussion on distance. Distance. See, let us choose one point A. This is your house. Okay, and your friend's house is located here. This is your friend's house. See, to travel to your friend's house, this is the street in front of your house, and here you have the turning, and that street pass before your friend's house this way. Okay, and behind your house a small and a narrow path is there to reach your friend's house, right? And here one important main road. Okay, many buses, vehicles travels on this. Okay, this is street, this is main road, so this is a main road. Okay, so from here you have another option. This is the way. Okay, this street actually meet the road here. This street meet the road here, right? So A is your house, B is your friend's house, right? Now I choose this path. Okay, you just get onto this street and you traveled this way. From A to the B, you have traveled this way. Now, what is distance? Distance means length of the path covered by an object is called distance. So now we have to measure the distance from here to here and from here to here. Let's say this point is something x. From A to x, the distance is 25 meters. X to B, the distance is 30 meters. Okay, or else I will make it easy, 30 meters, and this is 40 meters. Then what is the length of the path covered by you? So what is the path? This is the path you have taken. What is the length of the path? Okay, how do we calculate the length of the path? First, from A to the x we have to calculate. From x to the b we have to calculate, right? Then we get the length of the path. Now, what is the length of the path? Length of the path is equal to A to x, ax plus xb. These two we have to calculate. So what is the length of this ax? 30 meters plus what is the length of xb? 40 meters. Then what is the total length of the path? 70 meters. Okay. Now the 70 meters is the distance traveled by you whenever you choose this path. Okay, now from this what we can write the definition of the distance. Distance is nothing but the length of the path, the length of the path covered by an object is called distance. This is distance, length of the path covered by an object. You have started at A and you choose this path, right? Okay, along this path you have reached your friend's house. So this length of the path is 30, this length of the path is 40. The total length of the path what you have traveled is 30 plus 40, 70 meters. That is equal to the distance traveled by you from your house to your friend's house. Then how do you define the definition of the distance? Length of the path covered by an object is called distance. Its distance. Okay, is there only one way to reach your friend's house? There are many ways. You can also choose this way. This is one of the way, and you can also travel in the straight line. This is there. Okay, you can also travel this way. This is also one of the way. Okay, if you choose this way, I told you already here one narrow path is there behind your house, right? If you choose this path, then what is your distance traveled? Okay, if you choose this path, how do you find the distance? It look like a triangle, right? Right angle triangle, right? I will draw this. If you choose this path, what is the distance traveled? 70 meters. If you choose this path, what is the distance traveled? Let us calculate. Okay, so this is 30 meters. Okay, this is point A, this is X, and this is 40 meters. Previously you traveled this way and reached your friend's house. Now if you choose this path, this is the shortest distance between you and your friend's house. This is one of the path, this is second path, and this is the third path. Among all these paths, which is the shortest path? This is the shortest path. Okay, this is the shortest distance, right? The shortest distance between the initial and final point is called displacement. Okay, what is displacement? It is also distance. Distance and displacement both are different, but displacement is also a distance. But what is the main difference between the distance and displacement? If we talk about distance, you can reach your destination in any direction. In any direction. For example, this is east, west, north, south. Okay, your house is here, your school is here. Your bus driver first traveled this way. Okay, and then traveled this way, and some of your friends are getting to the bus here. Okay, and traveled this way, and some of your friends get into the bus, traveled this way, finally it reached the school. This is the school, this is your home. Okay, this way your bus is reached your school. This is the path, right? How many times you changed your direction, you tell me. So this is nothing but northeast. First you have traveled in which direction? Northeast direction. Then you have traveled in which direction? East direction. Then you have traveled in which direction? South. Then you traveled in which direction? West. Then you traveled in which direction? South. Then you traveled in which direction? East. How many times you changed your direction before reaches your school? Number of times you change your direction. Can we say you traveled only in particular direction? You haven't traveled in particular direction. Then how can we say? So here, this is distance. What is this? It's a distance. But what is displacement? Displacement is the shortest distance between the initial point and the final point. Now, this is displacement. This is home is your initial point, school is the final point. If I draw the straight line and join those, you'll get displacement. What is this? This is called displacement. It is also distance, but it is the shortest distance than any other distance. Okay? Here displacement has only one direction. You see? This is the direction of displacement. What is this direction? Southeast. What is this direction? Southeast. When we talk about the distance, direction, we don't use direction. To describe the distance, direction is not used. Okay? So distance have no direction. Distance doesn't have direction. Distance has no direction. Distance doesn't have direction. Right? So distance is a scalar quantity. The physical quantity which has magnitude as well as direction, those are called vector quantities. And the physical quantity which has only magnitude. Magnitude means what here? 70 meters is the magnitude. Magnitude is nothing but a numerical value. So this is a numerical value. It has only numerical value, but no direction. But displacement has both numerical value as well as direction. Here what is the direction? Southeast. Here also you see. So this is what direction? East. Right? According to this. Next, what is this direction? South. Right? Now I am going to talk about this. What is this direction? This is also southeast only. This is southeast direction. Now we are going to calculate this. So this is our displacement. This is distance. This is distance. But this is displacement. Okay? This is a length of the path. This is also a length of the path. This is also a length of the path. There are 3 paths to reach your friend's house. But which is the shortest one? That is a distance, displacement. Okay, the shortest distance is called displacement. Okay, the length of the path traveled by an object in one direction is called displacement. Covered by an object in one direction is called displacement. Okay, it is also displacement is also length of the path. Distance is also length of the path. But this length of the path, no direction, because here direction is changed. But this length of the path has only one direction. So displacement has direction. Distance has no direction. Okay, that is why displacement has direction. Since therefore it's a vector quantity. Displacement is a vector quantity. Now we are going to calculate the displacement from this picture. What is the distance traveled? 30 meters. What is the distance traveled here? 40 meters. And we have to calculate. This is displacement. Whenever problems are related to distances, related to sides, related to the right angle triangle, we use Pythagoras theorem. Okay, so what is the Pythagoras theorem which is related to these triangles? Here total this triangle has three sides. Okay, AX is one of the side, XB is another side, AB is the third side. Now we have to find the diagonal. Okay, so in trigonometry it is also called hypotenuse. The side which is located opposite to the right angle is called hypotenuse. We have to find this. If you want to find this, okay, the longest side, the square of the longest side is equal to the sum of the squares of the remaining two sides. That is a simple Pythagoras theorem. So if you want AB, you have to find the square of the AB. How? By finding the both squares and by adding them. Sum of these squares of these two, we will get the square of this particular side. Okay, now AB is equal to AX value, how much nana? AX value 30 square plus XB value how much nana? 40 square. So AB is equal to 30 square value 900, 40 square value 1600. Then AB square is equal to 2500, right? When left hand side we have square, right side also we can write. If it is possible, we write the square. Otherwise, we have to bring this square from LHS to RHS, becomes root. But 2500 can be written as the 50 square, right? 50 into 50, 2500. So AB square is equal to here. AB square is equal to 50 square. Square cancel. Then AB is equal to 50 meters. So what is the displacement now? 50 meters. This is the displacement. This is the shortest distance. The shortest distance is called displacement. But what is the major difference between this distance and the shortest distance? Distance has no direction. In any direction we can reach the destination. But displacement, we reach the destination only in one direction. Okay, so I hope you understand distance and displacement in this example. In this example, what is the distance traveled? Okay, so distance is called length of the path. First object traveled from here to here and here to here. This is distance. 30 meters plus 40 meters together 70 meters. What is the displacement? The displacement of the object. It is the initial point, this is the final point, this is the shortest distance between the initial and final point. The shortest distance we found with the help of the Pythagoras theorem. So 50 meters is displacement. But displacement has direction now. We have to write what is the direction of this displacement? Towards southeast direction. The displacement of the object is towards southeast. Okay. So with this one example, I hope you understand the differences between the distance and displacement. I repeat because to avoid the confusion, I repeat, distance is a length of the path. Displacement is also a length of the path, but this is the shortest than any other. It is a straight line length, straight line distance. The distance in one direction is called displacement. Displacement is also distance in one direction. That is a major difference between distance and displacement. I hope you understand the difference between distance and displacement. Okay, so I will give the definitions of both the distance and displacement. Already here distance definition I have given you. I will write the displacement definition. Otherwise I will erase this and I will write the definitions neatly. So take this example. First take this example, find the distance value and find the displacement value.